Awesome. And then, okay, here we go. Ready. 6.5. Oh, let me go black. Oh, I like purple, but we'll go black. 6.5, continued. And that was solving equations. Solving equations. Using containing rational expressions. Sorry. Containing rational expressions. We did, I think, 1 or 2 or 3 problems. I forget how many we did, but I definitely need to do some more. These are really important. So I want to make sure we do some more. First thing I want to talk about, though, I mentioned it really briefly, and I told you we would come back to it. And now we're coming back to it. Because now we're going to start seeing these. I want to talk about it. Extraneous solutions. Extraneous solutions is like, I think I said this way, it's like a fake answer, meaning that you're going to get the answer, but it cannot possibly be an answer. When you look for extraneous solutions, this is what you're looking for. When you get an answer, when you get a solution, when you get, I'll put solutions because you can have more than one. When you get solutions, if a solution or answer slash answer makes your denominator equal to 0, it is an extraneous solution. So you get your answers. You're going to see this in a few minutes. So you get your answers or answer, and you look back up and you look and say, oh, that answer is going to make my denominator 0. It doesn't count. Why? Because remember, we can never, like never, divide by 0. If we have something divided by 0, it's undefined. Same thing with these. It's impossible. You cannot divide by 0. So if we, wow, remember. So if you find an answer that if you plug it into the denominator and it makes it 0, it is extraneous, not possible. And we can't count that answer as an answer. So if this happens, that answer does not count. You can't use it because it's impossible. Okay, that's what it means by extraneous. It has to do with the denominator. The denominator can never be equal to 0. These are all fractions, so we have to think about that. All right, so let's do some examples. So examples. I didn't do one with any extraneous solution, but these will be mixed in. Some extraneous, some not extraneous. Okay, so all of them we were solving. And we'll start with this one, x over x minus 3 minus 7 over x plus 5 is equal to 24 over x squared plus 2x minus 15. That is a typical rational expression problem, rational equation problem. So what do we have to do? We have to factor any denominator. Very first thing we got to do. If denominator can be factored, we got to factor it. So I look here. I'm going to have to factor that. So first, we're going to write this down. These are fine, nothing to factor. but this one can definitely be factored. What can I factor it to? Well, 15, I can use 5 and 3, and that will give me 2. So x plus 5 and x minus 3. And there's no surprise that they happen to be right here. Use them as hints. It doesn't always happen, but most of the time it does. Then we're going to get common denominators. Since this has both of them, that's my common denominator. So all of them have to be x plus 5, x minus 3, minus x plus 5, x minus 3 equals x plus 5, x minus 3. That is my common denominator. Okay, so what am I missing from this? I'm missing the x plus 5. So I'm going to multiply the numerator and denominator by the x plus 5. And then I'm going to come back here and I'm going to put x. Well, we could probably distribute it, x squared plus 5x. So we just distribute. The second fraction, I am missing the x minus 3. So I'm going to multiply this by x minus 3. This one, be very, very careful because I'm going to make this red. See that minus sign? That means we also have to distribute the minus sign as we do this. So let me erase that. I don't like that. Okay, so what we can do is, I think I'm going to leave it. I'm not going to distribute. We're going to do the negative in a minute. We're just going to distribute it. So 7x minus 3, and then we'll distribute the negative next time. So distribute 7 to the x and minus 3, and then this last one is going to say 24 because it already has a common denominator. Now, what I want to show you is I didn't show you last time. I told you what to do, but I really didn't explain why. So if I multiply everything by the common denominator, which is what we're really doing, what happens? Well, that means this goes here, right? X plus 5, x minus 3. That's going to cancel. So I have x squared plus 5x. I'm going to distribute it here, x plus 5, x minus 3. They both cancel. Minus 7x, I'll be careful, plus 3. Distribute that negative times a negative is a positive. And then I would multiply this by x plus 5, x minus 3, and they cancel, equals 24. Now, last time I didn't tell you that. Go ahead.
Is it plus 3 or it would be plus 21 because 7 times 3?
7 is not in parentheses. Oh, yeah, it is 21. Sorry. Yes, it is 21. I wrote down wrong. 21 plus 21. Thank you. So last time I just said if you had the same denominator, you can forget your denominator. And that's the reason why. What you're doing is you're multiplying each of them by the denominator, which makes them all cancel. You don't have to show this. I just wanted to show you why it works. Because once you have the same denominator, you multiply all of them by the same denominator, they all cancel, and all you're left with is the numerator. And that's all. All right, so from now on, you can just say if they're all the same denominator, you can just write the numerator. This is only good if it's equal to them. Okay, here we go. So we have x squared minus 2x plus 21 equals 24. We're going to subtract 24. Why? Because when we solve, we have to have equal to 0. So you want to be equal to 0. Everything goes to the left. That's 0. X squared minus 2x minus 3 equals 0. All right, common denominators, 3. Simplify and solve for x, or solve for whatever variable it is, solve for a variable. And then I have one more thing to add after that. Okay, so we're going to solve. Now, solving because we're going to factor. We have a square, an x, and a number. That means factoring. X. I know it's going to be a 3 and a 1. Just figuring out where the negative goes. We want -2, so it has to be -3 and +1 equals 0. And then we learned last time to solve, we just set each of them equal to 0. X plus 1 equals 0. X minus 3 equals 0. And I'm going to solve them. So x is equal to -1. X is equal to 3. Now, I'm going to put it way down here, but here's my number 4. Check your solutions. What are you going to do? Look at your original denominators. So I have -1, I have 3. Let's go back. Scroll back up to the original problem. I had -1, I had 3. Do you see that if I put 3 in for x, I get 0 for my denominator? See it? That means 3 is an extraneous solution. I cannot have 3 as an answer because I will get an undefined. So this is extraneous, doesn't count. So my only answer is x equals -1. So this doesn't count, extraneous. This is my only solution right here. That's my answer, x equals -1. The only thing I can use. You do that every time. You go back to the original one, make sure your answers are able to be used. For instance, let's just say for a minute, let's say -1 is extraneous too. What do you put? No solution. We're going to do that in a minute. Now, while I'm thinking of it, your tests were 20s and 30s and 50s and 60s when I first looked at your grade. And I'm like, what happened to the test? And then I went to all your work and you were answering not wrong. Your answers were right. You were entering them wrong. So just to help you a little bit, I don't think they even have that. They have a bracket. And I can tell you half of you went x equals -1 and got all your answers marked wrong. So when you have the bracket, I forget the wording they give you. All they want is the answer in the bracket. That's it. If you have 2 answers, you do -1, 2, like that. And then you won't have them marked wrong. But oh my gosh, I saw 20s. I was like, oh, I've had a heart attack. The 20 want to be in like a 80 something or 30 want to be in like a 90 something. After I went through and checked all your answers. Also, for the factoring, be careful what you're entering too, because I saw a lot of this. X minus 1, x equals 4 when you meant minus or plus. So they were all marked wrong. When I looked at your work, they were right. So I fixed them. Just be really careful on entering your work because not everyone is going to check your work. I like to check your work to give you partial credit, but there are instructors that say, well, you didn't read the directions, so it's wrong. So just be careful how you enter your work, okay? Just for the future, be really careful how you enter your work. That just reminded me of that for a second. So, okay, let's go back. Okay, 2. 3x plus 2 over x minus 1 plus 2x minus 4 over x plus 2 is equal to 5. First thing I'm going to do is I'm going to put that 5 on top of 1. Give it a denominator. We got to find a common denominator, right? So the common denominator is going to be these two multiplied together. So let's start by putting it down. So x minus 1 times x plus 2 plus x minus 1 times x plus 2 equals x minus 1 times x plus 2. So that's my basis. I set it up. I'm ready to go. Now I can figure out what I can multiply by to fix all the numerators. So this one, first one, I need to multiply by x plus 2. Now, when it's a binomial times a binomial, it's really foiling or double distributing. So down here, for right now, I'm just going to write the parentheses. I'm not going to multiply yet. I'll do that next. I don't want to do too much at one time. And then this one, since I have x plus 2, I need x minus 1, which means I got to multiply this by x minus 1, but it's also binomial, so I have to FOIL or distribute. So I'm going to put that down in parentheses. And this last part, I need to multiply by both of them. I don't have either of them, which means I multiply the 5 by both of them. And I'm going to write that down here. 5x minus 1, x plus 2. So that's my setup. Everything is fixed. I have common denominators. Once I have common denominators, I don't need them anymore. And now I'm going to start multiplying. So I'm going to FOIL double distribute this first. The denominators are gone. So I get 3x squared plus 6x plus 2x plus 4. That's my first one, FOILed or double distributed. Plus, now I'm going to distribute this one. 2x squared minus 2x minus 4x plus 4. Second one multiplied out equals, this one I'm going to do 2 stages though. I'm going to keep the 5. I'm going to multiply, I'm going to FOIL this first. So x squared plus 2x minus x minus 2. Let me fix that so you can see it better. Minus 2. Now we have a mess, but we'll fix it. We're going to combine like terms, right? So we have, you can either do it in sections or do it together. I'm going to try to do it together. So I have 5x squared. I have 6x, 2x, negative 2x, and negative 4x. So 2x and negative 2x will cancel. I have 6 minus 4x, which is 2x. And then I have positive 4 and positive 4, which is plus 8. All right, now I'm going to do the other side. I'm going to, I think right here, I'm going to combine this real quick. X squared plus x minus 2, and then I'm going to multiply by 5. So I just combined like terms first. Now we could distribute 5x squared plus 5x minus 10. Now we want everything on one side, maybe, because I see something's going to happen. What happens if I subtract 5x squared? Gone. Gone, done. So really what I really have left now is 2x plus 8 equals 5x minus 10. I think algebra problem, I think I'm going to subtract 2x. You can do anything you want at this point. 8 is equal to 3x minus 10. I'm going to add 10 to both sides. 3x is equal to 18. So x must be 6. Oh, sorry, x must be 6. But let's make sure 6 is a good answer. So if I scroll back up to the original problem, none of my denominators have a 6. So I know 6 is a good answer, and this is my answer, x equals 6. And just to remind you, like any other math problem, you could always check your answer by plugging in x or 6 for x in the original problem, and you will find the answer is true. It takes a little bit, but you can do it. All right, questions before I do another one?
So do you, yeah, so do you even need to like do it like that? Do you even need to plug it in for X if like that number is in the denominator, or does that like automatically make it extraneous?
Yeah, okay, so automatically, if it's in the denominator, it's automatically out. It's extraneous. The only
Okay,
reason you
and it
would wanna-
doesn't matter if it's a positive or a negative?
Nope. Nope. Well,
Okay.
what do you mean by that? The denominator? So let's say my answer is 6. Hold a second. I might have thought the answer wrong. Let's say I have the original problem was x plus 6. That's fine. Because if I plug 6 in, I get x over 12. That's fine. But if my original problem had an x minus 6, now that's not fine anymore because x over 6 minus 6 makes x over 0. That would be extraneous. So in this case, x
Okay.
equals 6 is fine. In this case, x can't be 6. So that's extraneous. That makes sense?
Yep, thank
Yep.
you.
Okay. Yeah, no problem. No problem at all. Love it. The only reason you would want to plug them in, if you're, listen, it's really easy to make a mistake. Look at all this math we're doing, right? It's so easy to make a mistake. You saw me make a mistake earlier. It's really easy to make a mistake. You have to keep your head in the problem. So maybe you want to make sure it's right. So let's say you got to answer a 5, right? That's wrong. But if you put 5 into this equation, you're going to find out your answer is wrong. So definitely extraneous is out from the beginning. But let's say you just did something, I don't know, maybe you added and subtracted somewhere. Or maybe you did what I did, fract to multiply it through, right? So you can definitely check your answer by plugging in the number to x. And you guys have calculators, so you can do this real quick, just to see if I plug it in, does it equal 5? And you would find the answer is true. And that's only if you think you did it wrong. You don't have to plug them in. That's just like an extra safety to see if you did the answer right. Okay. 3. X plus 6 over x minus 2 is equal to 2. X plus 2 over x minus 2. When I was in school, like, I don't know, eons ago, because I'm a lot older than you guys are, I did not hand in my paper until I checked every single answer. I always checked my answer for every single thing because I want to know that I did it right. I wasn't that, okay, so you meet math people who are just naturally math people. I am not a natural math person. I worked really, really hard to be a math person. I went through a lot of failures. I was a nervous math test taker. I'm just like you guys, like I really am. I'm not like a natural math person. I worked really hard at it. So I always made sure I checked my answers because I was never like 100% confident I was right. And that's why I mention it all the time, because you can always check your answers. Okay, so this one is very different. We did one of these last time. It's basically a proportion that's equal to each other. So it also has, wow, look, it also has same denominator, doesn't it? Doesn't it both have x minus 2, x minus 2? So just like anything else, I can cross multiply, but honestly, I don't have to. It has the same denominator. So all I need is my numerator. Because if I multiplied both sides by x minus 2, which is what we would do, they would all cancel, and I'd be left with my numerator. So all I have to do is solve for my numerator. That's it. So x plus 6 equals 2x plus 4. We can solve for x. I'm going to subtract x. You can do whatever you want. I try to make x positive. I try not to go make it negative. And if I subtract this, so I got x is equal to 2. So no matter how you did it, I got x equals 2. But then go back to your original problem. I'll take out everything I just did so you can see it. Can x equal 2? No way. If I put 2 in either of them, I get 0. And we cannot have 0 in the denominator. It can't be. So this is extraneous. It's an answer that can't be an answer, basically extraneous. So how do you write your answer? This is what you'll see in your program. You will see one of two things. You'll see, okay, in my words, there's no solution. If you were doing a test for me on paper, you would put no solution, but you're not. So this is what you put on a computer. That's called the empty set, which means there's no solution. Or sometimes they give you the set notation and you leave it empty. That also means empty set, which both of them mean no solution in a symbol kind of format. So you're going to see either empty set, they're going to give you like choices, right? Or you're going to see this, and this is what you want to pick. This both means no solution in your computer. All right, question before I do it, I'm gonna make a new page. But any questions yet? No? All right, I have 2 more I want to do.
So that is that different or the same as like extraneous though?
The notation.
The no solution.
Okay, so no solution, it's different because I'll show you why. Let me go back for a second. This
I
one.
think I get it. It's like when x equals 0, but the other is like when your denominator as a whole is 0, right?
Yes, yes. And like this first one we did, we had 2 answers, right? We had one that was fine and one that wasn't fine. So I wouldn't use that symbol because I do have a solution. I had that as my solution. When everything is not a solution, you use that symbol. So this one, the only answer we have is 2, which is not a solution. That's when you use the empty set. When you have absolutely no answers left, empty set or no solution. Sometimes you'll get one that's extraneous. Sometimes you get non-extraneous, no extraneous, and sometimes you'll get all extraneous. So it just depends. If you have no answer left, it's no solution. And that's notation that we just talked about. Okay, so let's try. This was number 4, right? 4. Okay, 12 over 9 minus a squared. Okay, I'm not doing a. My a's look like 9s. Hold on. Minus, I'll call it y. I had a on my paper. I don't like a. Okay, 3 over 3 plus y equals 2 over 3 minus y. I like this problem because it's sort of kind of like backward problem. Don't we usually have y plus 3, right? But this one's, you don't want to change it because look how this is set up. This is set up backwards too. If I factor that, which I'm going to have to factor, it's going to be 3. It's a difference of perfect squares, just backwards. Y, 1 is plus and 1 is minus. And if you look at it now, they match. So you don't want to change it. Keep it in the order they gave it to you. Because when you factor it, that's what you get. So keep it. Okay, so that would be, hold on 1 second. Okay, that means if this is my factoring, and I have the other 2 already, that means that's my common denominator. So I am going to make all of these 3 plus y, 3 minus y. 3 plus y, 3 minus y. That's my common denominator. And now the first one is exactly what I needed. I'm not adding anything, I'm not multiplying by anything, exactly what I had, so it's just 12. The second one, I have 3 plus y, I need 3 minus y, 3 minus y, and now I can just distribute that because it's not a binomial times a binomial. So 3 times 3 is 9, 3 times negative y is negative 3y. And the last one last fraction, I have to multiply this by 3 plus y. So I'm going to multiply my numerator by 3 plus y, and I'll distribute it down here. And I get 6 plus 2y. Okay, so technically I multiply everything by the denominator and they're all going to cancel out. So all I need is my numerator. And then I can solve. All right, so combine like terms first. Okay, 21 minus 3y equals 6 plus 2y. I'm going to add my 3y. And I get 21 equals 6 plus 5y. I'm going to subtract my 6. And I get 5y is equal to 15. Divide by 5. I'm getting y is equal to 3. Now, we got to go back up to the original problem, right? I got 3. Can y be 3? It can be 3 here. Let me change my thing. I'm fine here. 3 plus 3, that's 6, right? But I cannot have 3 here. That is 0. So that means it only has to happen once. That means this is extraneous. Can't happen. It's extraneous. So my solution would be there is no solution. The only solution I had doesn't work. And then on your computer, it would be this or that. They might even have no solution too. I'm not quite sure. I know they have these two a lot. They might even also pop up no solution once in a while. Okay, did that make sense? It's the only answer we had. It didn't work, so it has to be this. And I have one more I want to do with you. And I think I feel like we did enough that I feel like you got it or can practice it and be fine. A 5. If you notice, they're all sort of the same. X plus 2 over x squared plus 7x plus 10 is equal to 1 over 3x plus 6 minus 1 over x plus 5. So first, we got to see if we can factor anything. So actually, we can factor 2 things. I don't know if you see it yet, but we can. So the first one, we're going to factor it. 2 numbers that multiply to be 10 but add to 7, that would be 5 and 2, right? So x plus 5, x plus 2. But this one I can factor as well. It actually has a greatest common factor. I can factor out a 3. And I would factor out 3, I'm left with x plus 2. Minus 1 over x plus 5. Oh, I don't want to put the 1 yet. Hold on. X plus 5. I mean, I can put the numbers, but I'm not going to, because I'm going to fix it. All right, so what's our greatest common factor? Well, I have x plus 5, I have x plus 2, and I have a 3. So our common denominator is going to be 3. Actually, I told myself I was going to fix it. I want to fix it. 3, that's my common denominator. 3x plus 5, x plus 2. So this one, and they could be any order. So I'm going to do x plus 5. And this one, I'm going to do 3, x plus 5, x plus 2. That's my common denominator. So let's see what we need. I have this part, I just need the 3. So this one, I'm just going to multiply by 3. And if I put it down here, it would be 3x plus 6 distributed. This one is this. So I'm just missing the x plus 5. So I know I need to multiply this by x plus 5, which means this becomes x plus 5. But 1 times x plus 5 is just x plus 5. And the last one, I had the x plus 5, so I need 3. I need to multiply by 3 and x plus 2, which is 3x plus 2, times 1 is just 3x plus 2. So I'll distribute it, 3x plus 6. Be really careful of this minus sign. Okay, so I have all common denominators. This means I don't need my denominators anymore. So I'm left with 3x plus 6 is equal to x plus 5. Remember to distribute that negative sign. Negative 3x minus 6. And now we can combine like terms. So 3x plus 6 is equal to, okay, that's negative 2x minus 1. I'm going to add 2x. And I get 5x plus 6 is equal to negative 1. I'm going to subtract 6. 5x is equal to negative 7. Divide by 5. And I just have a fraction answer. Always leave it as an improper fraction. So negative 7/5 is my answer, but we got to make sure we go back and check. Our original problems, when I factor it, we're looking at factoring too, because if it's factored, negative 7/5 doesn't have anything to do with any of the denominators. That's my answer, and that's my final answer. In your computer, you'll probably ask you to put it in like brackets like this. Just don't put x equals or y equals, just put the number in like that. And don't forget, you can always check your answer if you want to. You can plug it into the original equation. Hey, that's my last one. Any questions? Once you practice on this, you're going to get a little fun. Okay, no questions? Okay, we're moving on to next section. Now, this next section, we're only doing one type of problem. This section has a lot of different types of problems all in it. We're only going to do one type of problem. Your homework should only be one type of problem. If you did a homework early, you might see more than one type of problem, but I deleted some of them after if you started early. All right, so this is called rational, this is called, wait, 6x is called rational equations and problem solving. That's the name of the chapter. It goes into a lot of different kind of problem solving applications, but this is something that you'll learn next class. So really what I have to do is we have to do one type of thing that you'll need for next class, and that is solving for a variable. Let me put it this way, for a specific variable. So I'm going to give you an equation. You have to solve it for a variable, and I tell you which variable to solve for. These can be a little tricky too. I do have a couple of suggestions to help you along the way. So, number 1, solve this equation for W, which means at the end, I want to have W equals whatever's left behind. Here's my equation. You're going to recognize it. That should be a capital W. I wrote it sort of small, capital W. Anybody recognize the equation? You use it a lot. If you said perimeter, you're right. Perimeter equals 2 times the length plus 2 times the width. That's the formula. So this actually happens to be perimeter. That's not important. The important thing is that we're solving for W. So when you first do this, if you haven't done it in a while and you're not sure, I highly suggest you do the following. On your paper, grab grab a colored pencil, a pen, something different color. Wherever the variable is that you are solving for, make it a different color. Make it stand out. It helps your eyes focus on what you need to do. Why these are a little bit tougher, we have numbers in this one, but a lot of them don't even have numbers. There's a lot of different variables. So you just have to remember what you would do if they were numbers. So just like an equation, let's say I had 6 equals 8 plus 2x, right? What would I do first? I would subtract 8, correct? Same thing here, except it's not an 8, it's 2L. Subtract 2L, subtract 2L, because I'm trying to get to W. Because P and 2L are not like terms, I cannot put them together, and it is just P minus 2L equals 2, and then W. Just like if I had 2x equals 6, what would I do? I would divide by 2 to get x by itself. Same thing. I would divide by 2 to get W by itself. You can divide the whole thing by 2. I'll actually show you 2 answers that you could do. So my final answer is W is equal to P minus 2L over 2. That's one form of my answer. And either form is correct. You could have, let me do it again a different way, because I like to show different ways when I do problems. Whoops, sorry. That should be, there we go, equals P minus 2L. You could also do it this way. Divide by 2, divide by 2, divide by 2, because you can actually simplify it. This time, W equals P, okay, I forgot to put black, that's all right, minus L. That is another version of an answer. They are exactly identical, just written differently. Either you like dividing everything by 2 and leave it like that, or you like to divide each of them by 2, and that would be your answer. Either or is an answer. Each would be counted as correct. All right, 2. What's that? Okay. I don't know what this equation is for. Maybe somebody in the sciences. A lot of these equations are science equations. This one, I don't know what it's for. I am sure it's for something. Okay, and this one, we're going to solve for P sub 1. That's how you sort of say it. P sub 1. P1. So I'm going to go back here and I'm going to make my P1 red so it stands out. You can also use a highlighter if you rather highlight it so it stands out. It just helps you see it, what you should do and what you shouldn't do. All right, very first thing you should do. Well, we cannot get to T sub 1 until we get rid of L. L is like my whole denominator. So I need to multiply both sides by L, because that will cancel and I'll be left with little k, big A, and then I have my P sub 1 minus P sub 2, and this would just be HL or LH. Usually you go alphabetical order. Doesn't really matter. Now what do I do? Well, I still can't get to my T1 because I'm multiplying by KA. That means I need to get rid of my KA. How do I get rid of my KA? I can do it all one time because we're both being multiplied. So I can divide by little KA, divide by little KA. They will cancel, and I'm left with HL over little k, capital A is equal to, now I don't need my parentheses because I got it by itself. And then to get T1 by itself, I need to add T sub 2 to both sides. Add T sub 2, add T sub 2, and I'll show you how to write that answer. So T sub 1 is going to be equal to HL over little ka, and the plus T sub 2 has to go beside it like that. They're not like terms, you can't combine them. It has to go beside it like plus T2. You have to keep asking yourself, like, what would I do if it was just a regular equation? Would I add first? Would I subtract first? Don't feel like you can always go like, make an equation up. Y equals k x plus, oh, sorry, I meant to put a number. 8x plus 3 over 4. Something that looks similar. What would you do? I would multiply by 4 first, right? 4y equals 8x plus 3. Then it would divide by 8. That would be y over 2 equals x plus 3. Then I would subtract 3. And guess what? Exactly what we just did. It just looks different because a whole bunch of variables. But it's the same thing you would do for a regular equation. Same premise. All right. Question on those two before I do another one. I'm going to do a few of the next kind because they're a little tricky. I'm going to show you them. Actually, let me show you one that's not tricky. Let's do a basic 3. Y equals mx plus b. You've seen this a million times, right? How about if we solve for m? I'm going to change m to my color, highlight it or something. If you don't need to do that, that's fine. But I find it helps a lot if you sort of kind of get mixed up with what to do. What would I have to do to get to m? Well, I have to get rid of b. So I have to subtract b from both sides. I have y minus b is equal to mx. Whoops, sorry. I have to put black pen, mx. Now what do? How do I get rid of x? I divide both sides by x. You can do it 2 ways too. Let me do both ways. You can divide x by all of it or each one. It doesn't matter which way you do it. It's the same answer. M is equal to y minus b over x. If you did it this way, it'd be y over x minus b over x. Technically, since they have the same denominator, it should be the first one, but either way, sorry, either way would be correct. All right, so the real reason this is here, beside the ones we just did, is for the problems we're going to do next, because they're rational functions, which the whole thing's about rational functions. Well, I'm going to add a page, and we're going to do a few rational functions to show you how to do that. Oops, sorry. I hit the wrong button. What was the last one I did? 3? Okay, 4. 4. Same thing, just looks different. So we want to solve for R sub 1. I know this is a physics equation. I think it's for refraction, reflection, something like that. I took physics a long time ago, and I remember this equation. 1 over r equals 1 over r sub 1 plus 1 over r sub 2. So let me put my r sub 1 in red. That's what I'm solving for. Although it looks different, it is just like me saying, don't write this down. 1 over x minus 3 equals 2 over x plus 1 plus 1 over x minus 4. It's the same idea, the same concept, except instead of x plus 3, I have r's. What do we have to do? We have to get common denominators. So what is my common denominator going to be? These are all very different. R is different than r sub 1, which is different than r sub 2. So my common denominator is going to be all three of them. R times r sub 1 times r sub 2. They're all going to be the same. I'm going to make my r sub 1 red. I'm just going to write on top of it. All of them, just like we did before, we're going to put equals. We're going to do for each of them. R sub 1, r sub 2, plus r sub 1, r sub 2. I'm going to go back and make these red. R sub 1, r sub 1. So we have common denominator. We have our common denominators. We got to figure out what we have to multiply by. So the first fraction, I have r, which means I have to multiply by r sub 1 and r sub 2, which means I have to multiply the numerator by r sub 1, r sub 2. So 1 times r1, r2 is still r1, r2, but that means my new numerator is r1, r2. My second one, I have r1, so I have to multiply by r and r2, which means I multiply the numerator by r and r2. So my new numerator is r2. And then lastly, we have r2, which means I'm missing r and r1. So I'm going to multiply the numerator by r and r1. And I have r and r1. Lots of red everywhere. But it gets easier because I have all common denominators and I have an equal sign, which means all I need is the numerator. The denominator is gone. So I have r sub 1, r sub 2 is equal to r sub 2 plus r sub 1. Okay, questions up to that? It looks so much different than what we just did. It's exactly like we just did, just lots of r's instead of numbers and x's. So here's the trick. This is the one you have to be really careful with. See how I have r sub 1 on two sides? And they're in different parts. So first thing I have to do is I have to get r sub 1 on the same side. So what I'm going to do is I am going to subtract r sub 1 to both sides and get them together. So I subtract that. I have r sub 1, r sub 2 minus r sub 1 is equal to r sub 2. All I did was took the r sub 1, I subtracted it to the other side. Why? Because when you have what you need in two separate parts of an equation, separated different terms, I have r sub 1 in one term and r sub 1 in another term, I need it on the same side. because this is how you get R sub 1 by itself. So we have to get R sub 1 by itself. How do I do that? Well, I can factor it out, greatest common factor. So I'm going to factor out R sub 1, which means I'm dividing both of them by R sub 1. I'm taking it away. I am left with R sub 2 minus R. And I just successfully got R sub 1 by itself, almost. I got it alone. Equals R sub 2. And the very last thing I have to do is divide by the parentheses R sub 2 minus R on both sides, R sub 2 minus R, and I will now successfully have R sub 1 by itself. R sub 1 equals R sub 2 over R sub 2 minus R. And that's a lot for one problem, a lot. But you get common denominators, you write what you have left, and then you start going away. When you have what you need in two separate places, you have to get it on one side. You're going to do this a lot in algebra, by the way. You get it on one side, and then you isolate it by factoring it out. And then you solve the rest of it. So that's the trick. You get what you need on one side, factor it out, get it by itself, and then finish solving the equation. It's always that way. If you have what you need on two separate parts, you get it together on one side, factor it out. All right, questions on that before I do another one like it. We're going to do two more like it, just so you get a good feel for how to do these. And let's try another one. 1 over x equals 1 over y plus 1 over z. This will be sort of nicer if we don't have all r's. A couple of different, we have three different variables, but it's not like r, r1, r2. And we are going to solve for y. So I'm going to make this my red one. What do we have to do first? We have to get all common denominators. What are our common denominators? All of them multiplied together. X, Y, Z. X, Y, Z. X, Y, Z. Let's see what we need. So I have X, I need my Y and my Z. So I'm going to multiply my numerator by Y and Z. So my new numerator is Y, oops, sorry, I'm going to go back to the black pen, YZ. And let me go red first because I want to highlight my Y as we're solving for Y. So that second fraction, I have Y, I need my X and Z, which means I multiply the numerator by X and Z, and that means I have X and Z as my new numerator. The last fraction, I have Z, I need to multiply by X and Y. And then that means I have X and I'm gonna make sure it's red so it stands out, and Y. That is my new problem fixed with the same denominator. Once I have the same denominator, technically I'm multiplying by the denominator, which means I don't need the denominator anymore. And I'm just left with the numerator. So I have Y, Z is equal to XZ plus X, Y. All right, questions before I go on. I want to make sure you guys are okay. We got common denominators. And then we fixed our fractions, so they had the same common denominator. Our denominators will cancel because we're multiplying by the denominator. And then we have what's left. Notice now, this is the technique. I have y on both sides. I need y, I need to solve for y. So you get y on the same side. So you're going to subtract xy because you want y on the same side, minus xy. I'll put that in red in a second. So we have y z minus x y is equal to x z. Now that y is on the same side, I can factor it out as a greatest common factor. I'm going to take y out. And what am I left with? I'm left with z minus x is equal to x z. Now that y is isolated, we can solve for y. Divide by z minus x, z minus x, and I have my final answer of y is equal to xz over z minus x. Any questions? Okay, I want to do one more. Six. After this, we'll take like a 5-minute break, and we'll come back and do the last section, which is a completely different topic. So last one. Okay, so this is somewhat the same kind of equation, 3 over a, but it has numbers in it, minus 8 over b is equal to 5 over c. This time we're going to solve for c. Same procedure each time. I need common denominators. A, B, and C have nothing the same, so my common denominator has to be A, B, C. Since the denominators are going to go away, I'm not going to worry about putting the C as red. We need to worry about it now, though. I have A. For my first fraction, I need BC, which means I got to multiply by BC. So what I have is I have 3B, and now I'm going to put this as red, C. My second fraction, I have B. That means I need AC, which means I multiply the numerator by AC. And I have minus 8A C. My last one, I have C. That means I need to multiply by AB. And when I multiply by AB, I have 5AB. They all have the same denominator, so all I need is a numerator, 3B, C, minus 8, minus 8A, C equals 5AB. Now this time we have C by itself on one side. I mean, not by itself. We have C on one side. So now we just factor it out. We're going to take C out. What am I left with? 3B minus 8A equals 5AB. That means C is isolated. I can divide by 3B minus 8A on both sides, and I'll have my answer. So C is equal to 5AB over 3B minus 8A. And that's my solution. The one bad thing about these, really can't check your answer. You should be really careful with the math. Okay, so just to recap, you're gonna get common denominators, fix the numerators, don't need the denominators. Whatever you're solving for, make sure both of them are on the same side of the equation, whether you have to move it or not. Factor out what you're looking for, whatever variable you're looking for, and then divide what's left behind. I know I make it sound easy, but I know it's tricky. But that's sort of kind of what you're doing each time. Each and every time, that's what we did. Common denominators, we isolated, got the y by itself every single time. Okay, questions on that? That's the only part of this section that we're doing. If you don't have any questions, we'll take like a 5-minute break and we'll come back and we'll do our last section for today. Good? All right, so I'll see you at 3:15. How's that?